Okay, let's look at lesson 2223, and finally we're on the last part of this. So part 3, and it's all about writing the equations of the tangent lines today, which we've tasted just a little bit of writing the tangent lines. So some of this may seem a little bit refreshing or reviewing. Here's the derivative notation. It says there are several ways to indicate a derivative of a function, and we know derivative stands for the slope at a point. Given the function y equals f of x, the derivative y of f of x can be written as, well, one easy way is to say y prime. Another easy way is to say f prime of x. And finally, a third way is to say the derivative of y with respect to x. So you go dy dx. So those are three very common, or probably the most common ways. And equations of tangent lines, a derivative tells us the slope, oops, thought this was all clickable, the slope of the line tangent to a function at a given point. That instantaneous rate of change, that IROC idea. We will also want to write the equations of tangent lines. So not only do we want to get the slope, but often we want to write the equation. It's key to remember that a tangent line is just a line. And we all know how to write the equation of a line. To write the equation of a line, we always need two things. One thing we need is a point, and second thing we need is a slope, because we're writing linear equations. So writing this linear equation, if I do this on the function f of x at x equals a, my point would be a, comma, I need a y value, so if I plugged in a into my function f, that would give us the y value. So we'll just call it f of a. The slope can be found by examining the derivative. So we need that prime symbol, and we have f prime of a. That leads us to a point slope equation of y minus f of a equals f prime of a, here's our m for slope, times x minus a. This is that point slope form of a linear equation. If you want to compare it to the one that you know from algebra days, it would have looked like that. That's the one that we modeled, point slope form. Example 1, a function f of x is continuous and differentiable for all values of x. It's known that f of x, or f of 4 equals 7 and f prime of 4 equals 2. Write an equation on the line tangent to f of x at 4. So we want a tangent line at 4. Go see if you can highlight key information provided. Those are the three things that, or four things that I noticed. One, they talked about f of 4 at 7, f prime of 4 at 2, or equals 2. A tangent line is our task, and x equals 4, at the point x equals 4. Well, did they give you a point? Yes, they did. They gave us the point 4, 7, right over here. Did they give you the derivative, the slope? Yes, they did. It's f prime of 4 equals 2. Can I write my equation? Absolutely. Y minus the y value equals the slope times x minus the x value. You want to write above there where things came from? This is what we did. I should put, oh, that's fine. We'll leave the 4 there. Okay. That was an easy one. Everything was provided. Let's look at example 2. The function g is defined as g of x equals. It is known that the derivative of f is defined as g prime of x equals 2x minus 3. Write an equation of the tangent line to g of x at x equals -1. So information given. See if you can highlight it. What was the task that we're supposed to be doing? We're going to write the equation of the tangent line. Okay, so we need a point. Did they give you the point? They gave you half of the point, didn't they? They gave you the x value. So we were given x equals -1. Now we need to find the accompanying y value. So I go to the original equation, which they gave me, g of x equals x squared minus 3x plus 5, and I evaluate it at -1, so that I can find my y value. Once we get this written out, do the math, and let's see what it comes out as. I'm getting 9. Is that what you got? G of -1 is 9. That creates an ordered pair for us, and I often like to just go in and, write that ordered pair so it's just very blatant to me what x and y were. The slope. Use the derivative equation. Did they give you the derivative? Yes. So we were given g prime of x equals 2x minus 3. We want to evaluate it at -1. Notice how this notation, I'm writing evaluate, this notation tells us exactly what's going on. I'm substituting -1 into the slope equation, the tangent line. All right, so 2 times -1 minus 3 looks like that would turn out to be -5, doesn't it? And I'm just going to write g prime of -1 equals 5. Now let's write the equation. Y minus the y value of 9, taking that from right there, equals the slope, x minus the x value of -1. So I have a minus -1, which will turn out to be plus. On to example 3. The function f is differentiable for all x's with selected values of h and h prime in the table. See if you can highlight using different colors h and h prime. Notice it? Awesome. Write the equation of the tangent line to h of x at x equals 1. What are we trying to do? Write the equation of the tangent line. Where are we doing this? At x equals 1. So in my table, I go find 1, don't I? All right. So I think I'll probably be using those 2 items in that column under x equals 1. All right, what is our point? We were given x equals 1. So we look it up. I'm looking up h of 1, and I come out with -5. It's in the yellow, isn't it? Up above in the table. Next, the slope. Well, we were only really given the fact that we had x equals 1. So I look up. Do I have h's, function h for all values? I'm sorry, it's, oh, okay, I thought I wrote down g. Must have been from the given. Okay, look up h prime of 1, which indicates the slope, and I notice that that's -4. So I have an ordered pair of 1, -5, and a slope of -4. Now go in and write your equation. See if you can write it, pause, and then come back in. There's the equation of the tangent line. A y value of -5, so that created a plus, an x value of 1, that created x minus 1, and then our slope of -4. Getting the hang of these? Number 4, write the equation of the tangent line h of x at -2. I want you to walk through the steps on this, so hit pause, and then come back. All right, here are the things I found. First off, I noticed that the point was taken at -2. I looked up the table and came up with 3. Next, I went to the h prime part of the table and looked up h prime of -2, and it came out as 0. That's a horizontal tangent line. I could probably stop right there because I know horizontal tangent lines would have a y equals equation, and then I could grab the y value and come up with the fact this is going to be y equals 3. If you didn't recognize that, you could proceed and it will work out. So I wrote the equation of the tangent line, y minus 3 equals the slope 0, x minus negative 2, so x plus 2. Well, 0 times anything on the right is going to produce 0. Add the 3 over, and then we've got that horizontal tangent line, y equals 3. Next it says, let k of x equal the quadratic that was shown. Write the equation of the line tangent to k of x when x is 3. So we've got to find everything on our own. No table to look up this time. Highlight some important information. And then please highlight in blue or some other color what you're trying to do. You're writing the equation of the tangent line. All right, first thing let's find the point. We were given x equals 3, so I need to do a k of 3, don't I? And that's going to be a 3 squared plus a 5 times 3 minus 3. That's a 9 plus a 15 minus 3 equals 24. 24 minus 3 is 21. That gives me an ordered pair of 3, 21. Next, let's go find the slope. The slope, is k prime, isn't it? Darn, they did not give that to us this time. Well, that's a shame, isn't it? So, in order to find k prime the long method, I'm going to go back to the limit as x goes to my value c. I'm going to evaluate f of x minus f of 3 over x minus 3. So as this comes close to 3 from the limit, this that's a denominator. That denominator is going to go to 0, isn't it? Which is a limiting process and gives us the derivative. So that's going to look like, you know what, I'm going to just keep extending horizontally because I have more space that way. F of x, well, f of x is my highlighted yellow, so x squared plus 5x minus 3. Take away f of 3, so plugging in 3 I have, well, we already did it once. We plugged in 3 and we got 9. But, you know what, for your notes, you might just want to show what we did to get that. And I just noticed something. I did not write the word limit. Shame, shame, shame on me. The limit as x goes to 3. Okay. Now it's all about simplifying, isn't it? Let's keep simplifying. Now it's kind of back to what we were doing in chapter 1 when we worked with these quotients differences. And 15, 12, 21. Yeah, we had calculated that before. You know what, rather than doing that, well, no, let's go ahead and do that. That is 21. So I have an x squared plus 5x and a 3 minus 21 giving me a negative 24 over an x minus 3. You know where this is going, don't you? We should be trying to get some cancellation. The denominator is our problem, so see if this is factorable. It certainly is factorable. That removes, and now we just go 3 plus 8. Oh, we finally found our slope. This represents k prime of 3. And let's take and go back to our original, because we didn't find just a general derivative, we found the actual derivative at 3. It is 11. Yeah, that's fun, isn't it? Okay, so now we're going to write the equation. So the tangent equation is, my ordered pair was 3, 21, and my slope was a k prime of 3 was equal to 11. So that's going to be a y minus 21 equals 11 times an x minus 3. And you're done. You do not have to convert these equations. This is perfectly acceptable to the AP. Now, having said that, there are times in multiple choice where they will definitely take it into mx plus b. But I'm going to trust that you can do the algebra and solve for y. Example 6, this is a calculator active one. So, pop up your calculator. Oops, gotta get a pointing tool going on here. So get your calculator warming up and we'll use it here in a minute. It says the function p is defined as p of x equals natural log blah blah blah. Write the equation of the line tangent to p of x at x equals e squared. Whoa. All right. Let's use our highlighter just like we did before. What were some of your givens? And then what are you trying to do? Tangent line, right? Write the equation of the tangent line. What do I need to do that? I need a point. I need a slope. The x value is going to be an e squared. And that means the slope's going to be a p prime of e squared. And they said we can use our calculator. I think this is a good opportunity to go into that y equals, back to highlighting here. We go back to y equals, I'm going to clear yesterday's work, and let's go with natural log of x squared plus 7. Oops, not 4, 7. It's in y1, so keep that in your head or write it down. Now, I want to evaluate y1. How do I get to y1? I go alpha f4. So I get trace, and then I've got to grab y1. I want to evaluate it, so use a parenthesis, so we can go like y sub 1 of, and I'm going to put the e squared in, and that's going to give me my answer in the calculator. Second, e to the x, square that baby. You can close the parenthesis, it's not necessary, but you can. And that's going to turn out to be, how many decimal places of accuracy? You need 3. I'm going to go ahead and round, so I'm going to call it 4.121. Now the next thing I need is the slope. So I want to do the derivative function. Do you remember where to find it? Either Math 8 or Alpha Window, excuse me, option 3, the derivative with respect to x. Our function, I don't need to rekey, I can go alpha trace, option number 1, get my y sub 1, and we want to evaluate this at e squared. Boom. And 3 decimals once again, 0.2, I'm going to round on this one, 240. Hey, that calculator was a huge help. I didn't have to do it all by hand. So I have my ordered pair, y minus 4.121 equals, I have a slope, 0.240 times an x value, x minus e squared was our x value. And there's our equation of our tangent line. Sweet. Yeah, I like it. All right, that concludes today's lesson. I think you'll find that the worksheet is very similar to the work we just completed. So good luck on it.